We begin with our Unit 3 of Advanced Financial Modeling. And in this unit, we are going to kind of try and understand the financial modeling for FSA and valuation. So when we have a company's statements given to us, how do we use financial modeling to understand what's going to be the subsequent values that we are going to get, and how are we going to project data for the future? So we are basically looking at projections or projecting financials in the future, right? So future values is what we are looking at, because under valuation, we will have to use those forecasted values. Even if we use something like NPV or IRR, we need forecasted values in the future to be able to arrive at whether the project makes money for us or not, right? So there are segments in this particular unit that we will look at, and we will also address how do we create dynamic models that link with each other during the course of this particular unit, right? So we'll first start with an understanding on forecasting revenues and costs and what could be possible methodologies to do that. The next part that would come would be projection of revenues, costs, and other income statement items and nuances around that, followed by projection of balance sheet items and data points around that. Uh, Selecting, the model drivers and assumptions, creating a dynamic model for financial statements, and modeling need for financing in future time. Right. So basically, we're going to look at what kind of financing might be needed at a later point of time, what kind of data would be required there, and if a company were to go for M&A, what really would it have to do in that context, right? The basic premise here, however, is that we have to start with the discussion around how do we forecast revenues and costs, right? So the basic problem statement that we have is, if we have been given a company like this, where we have been given sales, we have been given raw material cost, and we have been given net profit, and we have to forecast data here or find data here. Let's say we are standing here and we are trying to forecast data for the next 4 years or 3 years. How do we really find out what is going to be the exact sales or projected sales for 2013, 14, and 15, right? Now, there are various ways to do that, is figure out historical growth and base it on that. In some of the cases, we can use proportions as well. So where does proportions work? Proportions work with things like raw material costs. So like raw material cost as percentage of sales. We can try and find that out. And we can see what kind of growth has been exhibited, and we try and project it based on that. When we are looking at historical growth, we are basically doing what is called as trend analysis, right? We are basically going around doing trend analysis. So let's try and gauge, if we are given this data, what are the various ways we can project or find the forecasted values in the future, right? For this, we'll have to go to an Excel file. So that's our data replicated in an Excel file, where we have the sales data, where we have the cost data, and where we have the net profit data, right? Now, just for our benefit, what I'm going to do is I'm also going to put the growth data here. So growth in all these three items, and growth can be calculated year on year growth, right? Every year, what is the growth? So I will find out what is the difference between today's value and the previous value, and divided by the previous value, right? And so we get a 19% growth here, and so on and so forth. I can drag it here, and based on this, we can arrive at some sort of a growth number, right? So that's the basic growth range that we have received or calculated based on our data in terms of these 3 years for the company. Now, what is the possible thing that could be done? One way is, let's say method one is historical average, right? So I can take the historical average. What is the historical average? I can take the average of these 3 years, what kind of growth has been there, and same for these three. And because this is a projection, I'm going to just color it differently. And we say that because that's the historical growth in the last 3 years, 19%, 51%, 59% growth in the 3 years, the average should be something an average of these three, which is 43%. So this year's sales number based on the average growth is going to be last year number multiplied by 1 plus 43% and so on and so forth. So we get some sort of a projection that comes because of this, right? This is similar in nature to something called as trend analysis, right? So that's the first method of forecasting which we have just used, which we have taken averages of historical growth. We can then take the next method, which is, let's say, the forecast method, which is nothing but the trend analysis. So what does trend analysis do? It basically does what is called as linear regression, right? What is linear regression? So let's remove this data here and try and identify linear regression. If I were to plot a chart between these two data points, I can go to insert and I can plot a 2D chart between this data. I don't need this series, so I can remove it from here. And I find that there is some sort of a relationship between the number year, and the sales, right? And what we can do is we can add a trend line to this. And as we add a trend line, Excel gives us the option on the right hand side to display the equation on the chart. So I can display the equation on the chart, and that equation basically says y is equals to 253.74x plus 68.265. That's the broad equation that we get, right? I can actually try and copy this equation, and we can probably paste it somewhere here, right? That's the equation we have pasted. Now the trick here is to actually find out what is y and what is x, right? So y is the final value we are coming at, x is the year value, right? So 253 into 74. So if I put x equal to 4, then the value would be 253.74 multiplied by 4, because x is 4, plus 68.265, and we get 1083. So that's a close match based on the trend line. It's not the exact match, remember. If we look at the exact point is somewhere here, but the line basically shows that the point is somewhere here. So that's the trend analysis that we are doing. If, however, I replace x equal to 5, so if I was to put in x equal to 5, that's the next year data. This is the data we are trying to find out when I say x equal to 5. What is the sales going to be based on this equation that we have just calculated? So let's actually just do that. All I need to do is copy this formula down and change 4 for 5, and we get 1337, right? So I can put 1337 here. So what have I done? I have basically found the trend line, displayed the equation. In other words, what we have done is we have done linear regression. So if we do the linear regression, we get this value, right? Linear regression can also be done using another formula. What is that formula? That formula is called as forecast. So there's this forecast ETS that we could use, or we could just use forecast. Let's use forecast to begin with. When we use forecast to begin with, you will find when we open the arguments, it says x being the value for which we are forecasting. So in our case, x is 5. You will note that it is very similar to what we are calculating, what we were calculating in our discussion around the linear regression, right? What are the known y's? These are the known y's. These 4 values are the known y's, B8 to E8. What are the known x's? That's these 4 values, right? And when I click OK, you find that we get the exact same value. If I add decimal points to this, we will get the exact same value that we found here. So in a way, the forecast function does what we wanted to do using linear regression or taking this equation into consideration, right? So forecast function basically gives us a linear regression equation based on our calculations. Now, forecast obviously comes with a certain set of options. So When I'm forecasting for the fifth period, I want data from first to fourth period to be with me. But when I'm forecasting for the sixth period, I want data all the way up to here. So we can write this here as well. So let's use forecast. And in newer versions of Excel, you find a lot of these other functionalities that also come in. We may not need to discuss them for now. We can probably take them at a later point, right? So G7, what are the known Ys? These are all the known Ys, and these are all the known X's. And we can close the bracket and we get the next value. Right? So for the sixth year, I'm using data from year 1 to 5. For the fifth year, I was using data from year 1 to 4. Can I actually freeze this somehow? Right? So what do I want to freeze? When I drag it on the right side, I want the last column to change in a lot of these data points, right? So B8 needs to be fixed, but E8 needs to change when I drag it on the right side, right? Similarly, when I say B7, B7 needs to be fixed, but E7 needs to be changed when I move on the right side. F7 needs to be changed when I move on the right side. I press enter, I can just drag it here, and you find this automatically moves on the right side, right? So those are the forecast for the next 3 years. I can do the same with net profit and raw material cost. So let's put forecast here, let's say for the net profit, and we could look at X, we could look at the known range where we freeze the range at the beginning, and we can look at the known values here, the X's, and we can freeze this value here, and we can close this here. Correct? Enter. So that's 222. And because we have frozen those two, it's simpler to project it. We can also do the same for raw material cost if we want. However, there is a third method of projections, and usually you use this with costs, is the proportion method, right? I'll just remove these. We're using the proportion method, and typically used as, for cost as percentage of sales. So I can use cost as percentage of sales. And so what is the cost as percentage of sales? Let's try and identify that from our file. Let's just reduce the size a little bit. So find RM cost as percentage of sales. Correct? I can do that. And we can drag it here, and we can find it out here. So that's my raw material cost divided by the sales, and that's 57% in the first year, headed all the way up to 59%, but there is a broad sense of average that is there, and I can take an average of these because it's hovered between 57 and 62%, and I can say whatever is the average multiplied by the sales is going to give me the cost number. We understood? We said every year the cost is a certain percentage of sales. Every year the cost is a certain percentage of sales. Once we took that identification on what is the broad cost as a percentage of sales, we then took the average of that. Once we took the average of that, we basically clubbed these two data points and tried, because we've already forecasted the sales, we can now arrive at the cost number based on our assumption on what is going to be the cost at as a percentage of sales in this particular year. I can actually do the same for subsequent years as well, and that basically gives us our data. So we can drag it here, and we can drag this here. This, remember, is the third method, which is proportion of a percentage of sales typically. That is commonly used in a lot of the cases. What it inherently means that the margins of this company will remain fixed, because for a certain amount of sales, they're only going to have a certain amount of cost. They can't move independently of each other, is our assumption in this, right? So that's the forecast function that we have used. There are some other functions that can be used as well to arrive at almost a similar set of data, what we have discussed so far, right? So there is a function, for example, called trend, that could be used to arrive at a similar data. But at this point of time, we probably don't need to get there because it's going to do the same functionality what the function forecast did for us. So the one new function we learned was forecast, and that basically gave us the broad idea about what kind of projections would happen here, right? Now, let's go ahead and try and see what are the issues with this. So we projected it and we found the data for 2013, 14, 15. And if you remember, the data said 1337, 1591, and 1844 based on historically what's been the trend, right? Based on historically what's been the trend, it is this trend line that got extended further, right? Now, if we want to extend this to understand how it plays, let's see what happened with the company in real life, right? So the forecast was the orange line, and that's a straight line. We can see that it is a straight line, but the actual numbers went ballistic somewhere else. So in 2014, our forecast was somewhere around 1600 crore. The number came in at close to about double of that with a 3200 crore. In 2015, our forecast was close to 1900 crore. The number came close to 7000 crore. That's about 3.5 times of the actual forecast, right? So the forecast versus the actual was varied by a very, very wide margin. And that margin kept increasing as we went into the future, right? That tells us something about the limitations of what we can do using mathematical forecasting. What we did was linear regression. But in real life, what you could find is exponential movements. We can do an exponential regression or exponential trending as well, but real life moves not in sync with what mathematical formula tell us, but more in terms of what the company is trying to do. So if the company does well, the numbers could go up significantly more. If the company does not so well, the numbers could go down significantly as well. What is important is that we all realize that these are real companies with real people who are running these businesses, right? Businesses can surprise us. So it is very important that when we make the forecast, we understand the business. Understanding of the business is paramount for us to make the forecast. What we did so far was just a mathematical extension of what we have seen. It doesn't tell us anything about the business. We never asked a question about what is this business, what is it growing at. When we get into the actual forecasting for financial modeling, to build a good, robust model, it is very, very important for us to understand the business. And it is very, very important for us to answer the question, how does the revenue get calculated? How does the company make money, right? So here is what we need to do to make accurate forecasts, right? We need to understand the business and its drivers. That is paramount. We need to understand how does the business make money and how does it spend its money. And remember that real life forecasting is far, far more complicated than simple linear trend projections, right? So in real life, companies can make money and lose money depending on what decisions they make, what are the industry conditions. So it is important for us to basically try and find out some of that data. How does the business make money? What are its drivers? How does it spend money? What are the drivers of the costs? And the fact that in real life there are events that will shape how these two processes go ahead in the future, right? That's basically important in terms of understanding how to make accurate forecasts for the purpose of financial modeling, right? Now, as we end this particular section, this video, please try and answer this question. You have been given a company whose sales and net profit numbers are given. Please use the function forecast to find the data for the last 2 years or 3 years. Also use net profit as a percentage of sales to find the data for the net profit for these 3 years, right? Forecast is to be used to find the sales data, and net profit as a proportion of sales has to be found using historical data and averages there, right? That's it in this particular video. Thank you.